Today we're going to talk about area between two curves. We've looked for at area under a single curve. So today we're going to look at what happens if we want to find the area between two different curves. So just to kind of get at the concept for a minute, let's think about a square with a circle inside it. Seems like the kind of problem you'd see on the SAT a lot. And one question they like to ask is, what would the area between that square and that circle be? Well, think for a second about how we could find that area that I just shaded in, the area between the square and the circle. And the way you would actually do it is you would find the area of the square and you would subtract from that the area of the circle. And that would give you what's left over. So you do the area of the square minus the area of the circle. So basically you take the bigger object, you find its area, and then subtract the smaller object, what's inside it, from it, and you would get what's left over. So it's a very similar idea with area between two curves. You do the area of the top equation minus the bottom equation. So it's top minus bottom. F of x should always be the one on top. And that brings us to a second point, that your answer should never be negative for this. It is possible when you're just doing a regular area problem, in other words, area under a single curve, it is possible to get, sorry about that, it is possible to get a negative, but when you're doing the area between two curves, your answer should never be negative. And in fact, if you do get a negative answer, what's probably happened is that you put the wrong thing first and you switch this order. So if you do get a negative number, go back and double check that. And we'll talk about how to make sure you know which one's on top in just a minute. Okay, next thing we're going to look at is the fact that there are two basic types of problems that you're going to have to solve. The first type is two curves that don't ever intersect, they don't meet, and so in that case basically arbitrary boundaries will be given. I mean, if it's a word problem, there certainly could be a good reason they're choosing those boundaries. I'm just saying that you could choose different boundaries and still do this problem. Basically, if the two curves don't intersect, they're going to have to give you the boundaries. That's the bottom line. Now, if the two curves do intersect, then most often they're going to ask you to find the boundaries. And that boundaries will be those points of intersection. So number one has an example right over here. And then number two has an example right down here. So these points of intersection that I'm highlighting right here in green, those would serve as the boundaries for that problem. Let's look at an example. It says find the area of the region bounded by y equals x squared plus 2, y equals negative x equals 0, and x equals 1. So this is an example of that first type of problem where they don't intersect and so boundaries are given. Anytime you see vertical lines like x equals 0 and x equals 1, those are going to serve as our boundaries. Okay, so just to give you, I'm not going to usually sketch these, but just so you get an idea what this one looks like, here's x squared plus 2. Here's y equals negative x, so you can see they don't intersect, and so it gave us boundaries at 0 and 1, and it wants us to find that area in between. Now that's just a rough sketch of that, but that gives you an idea of what we're doing. So we set up an integral from 0 to 1. Again, those boundaries are the x equals 0 and x equals 1. Then we need to do the top equation minus the bottom equation. Well, you can tell by just looking at our picture that the x squared one is on top. So x squared plus 2 minus negative x. Now, it's a couple things that are important as far as good habits. You should put parentheses around the whole thing with dx at the end. And it's good to put parentheses around this second function. It didn't matter so much on this one, but anytime you have more than one term, it's going to be very important to get the correct answer because you have to subtract the whole thing. So let's go ahead and simplify before we take the antiderivative. I'm going to rewrite this as x squared plus x plus 2. You don't have to do that, but I usually find it helpful personally. Then we take the antiderivative. We get 1/3 x cubed plus 1/2 x squared plus 2x. and we're doing that from 0 to 1. So we plug in 1, we get 1/3 plus 1/2 plus 2 minus, if you plug in 0, you get 0. And if you work that out, it should be 17/6, which is 2.83 repeating. So the area between those two curves, that area that I've shaded in blue, is 17/6. Okay, one thing I want to go ahead and explain is how to figure out which one's on top. Obviously, I drew the picture on this one, and it was quite easy to tell just by looking at the picture. But sometimes you're not going to have a calculator, and you may not be able to do a sketch by yourself. So you need to know which one goes on top. Okay, the key to that is to go over here and look at the boundaries. So our boundaries were from 0 to 1. Now the key is to pick something between 0 and 1. I would just pick 1/2 in this case, and then we'll plug it in this equation. If you plug in 1/2 here, you get 2 1/4. If you plug in 1/2 here, you get -1/2. So clearly 2 1/4 is bigger than -1/2. So this equation is going to be the one that goes on top, and that's why we do that. So the way to figure out which one goes on top again is to look at your boundaries, pick a number between those boundaries, plug that number into both your equations, and whichever gives you a bigger result, that's the one that goes on top. Alright, so let's move on and do another example.